Hello and welcome back to our video series Component Explained. After watching this video, you will know how to edit your Rhino lights with Grasshopper using the query model lights and light attributes components. As usual, we're gonna cover this with an example. Here on the right, I have a horrible looking starlight on the roof of a room, and we are going to use Grasshopper to fix this. The starlight is constructed from point lights. Now the first thing to do is to query the model lights from Rhino. You can use the object name or object layer as a filter using the match method input modifiers. As an output you get the lights, or if you want to filter this even further, you can select the type of the light you want. To demonstrate, I am using the layer with a wildcard expression to get the point lights from the model. Next we're gonna move to the light attributes. By looking at the model, the first thing you notice is that you cannot even see the walls of the room. This is because we have 100 lights and the falloff function is set to constant. This basically tells us how it's going to calculate the light intensity on the walls or other objects that the light touches. So how I have understood this is that the constant function will apply the same intensity of light on all of the object surface. So for example, if the intensity of this point is 1, it's going to apply the intensity of 1 to here also, which is not how the light works in real life. So you have 3 different types of fallout functions: constant, linear and inverse squared. We're gonna change this to linear and see that we're starting to see the corners of the room. Now using the linear falloff function is not physically correct, but it is faster than the inverse squared calculation, and you can achieve pretty much the same results, but you have to use less intensity when you are working with the linear falloff and more intensity when you are working with the inverse squared one. Here is a comparison of 2 models, one with the linear falloff function and intensity of 0.03 and one with the inverse squared falloff function and intensity of 100. Now the light is still too intense, so we're gonna adjust the intensity parameter. As you see, calculating the lights is not always the fastest thing to do. Now with the shadow intensity you can adjust how dark the shadows are, so these two inputs works as a brightness and contrast. Now before we go any further, you need to know that the rendered mode and the ray traced mode will result in different outcomes. If your computer can handle it, I recommend that you use the ray traced mode. And the second thing to know is that the lights that are rendered in OpenGL will often clip through objects. What I mean by this is that they will sometimes go through solid objects in the preview mode. This is why it is important to test and try and actually render your outputs. Let's change to ray traced mode now. You can do this by clicking on the small arrow on the top left of your viewport and click on the ray traced. As you see, the lighting looks very different from previous and much more natural. Now I'm going to adjust the intensity again. Okay, now I'm happy with how the lights look. If you want to quickly turn the lights on and off, you can connect a boolean toggle to the enabled input. If we want a real star field feeling, we can adjust the color of the light. Let's try something bluish. If you want to quickly go through different light temperatures, you can create a gradient for that. I'm just using the Inferno gradient to demonstrate, but you can connect the gradient into the color and start sliding. I think I'm happy with this lighting. That is all for now. If you learned something, hit the like button and subscribe to the channel if you want to keep on learning.